In this video, we will see about the different types of energy sources. So see this circuit. Here you have two energy sources, a 10 volt voltage source and a 6 volt voltage source. So in this circuit you have a voltage source as well as a current source. So this voltage source and current source are called the energy sources which supply the energy to the whole circuit. So the voltage source can be an independent voltage source or a dependent voltage source. Similarly, the current source can be an independent current source or dependent current source. Let us see what do you mean by an independent voltage source. If you take this one, this is a 230 volts DC voltage source and this is 230 volts AC voltage source and this is a battery. So in all these cases, whatever circuit I connect here, if the voltage remains constant. So however the circuit is, if the voltage remains constant, then it is called an independent voltage source. That is the voltage source whose output voltage does not depend upon any other parameter in the circuit. We call it as an independent voltage source. Example, this cells on batteries. Suppose if I connect a DC motor here, it may draw 10 amps current. So in that case also this voltage remains constant. So if it remains constant, we can call it as an independent voltage source. Similarly, an independent current source is one whose output current does not depend upon any other parameter in the circuit. Now let us see what is a dependent source. You take this circuit, you have two current sources here, 5 amps and 3 amps. These two are called independent sources. That is, whatever happens in the circuit or whatever changes happen in the circuit, this current magnitude remains always 5 amps and this always remains 3 amps. So they are called independent current sources. Whereas you see this part, here also arrow is there, it indicates that it is a current source. But you see the magnitude, it is written as 2 into ID. So what is ID? ID is the current through this 1 ohm resistor. Suppose the current through the 1 ohm resistor is 10 amps, this will be 20 amps. So as the current through this 1 ohm changes, this will change. So this is called a dependent current source. So it is also called a controlled source because some other parameter is controlling the magnitude of this source. So a current source whose output current depends upon either the voltage or current of any other part of the circuit, we call it as a dependent source. Let us see where these dependent sources are used. It is mainly used for study purpose, to study the behavior of electronic devices. This is a transistor. This is called the small signal modeling of a transistor. How the collector current will vary with respect to the base current. That can be represented by a dependent current source. Similarly, for an op-amp, this is the circuit. So for different devices, you will have a different circuit, and normally since one parameter, this collector current depends upon the base input, it is represented by a dependent source. There are types of dependent source. One is the voltage controlled voltage source. It means that it is a voltage source, but its value depends upon voltage on or voltage across some other element in the circuit. So this will be represented by V is equal to K times V1. This K is some number. It may be 1, 2, 3, 4 something. So V is equal to K times V1. So it is a voltage source whose output voltage depends upon voltage in some other part of the circuit. Another is current controlled voltage source. So this is also voltage source, but the voltage magnitude depends upon current in some other circuit. Next is a voltage controlled current source. So it is a current source. The magnitude of the current source depends upon voltage in other part of the circuit. And current controlled current source, the magnitude depends upon current through some other resistor. So there are four types. We can see one example for this. So if you take this circuit, you have two independent sources. This is a voltage source and this is a current source. So 11 amps and 2 volts is represented here. If you see here, it is represented by a diamond symbol. So it is a dependent source and it is written here 6 into Ix. What is Ix? Ix is the current through this 2 ohm resistor. So it is a voltage source, but it is current controlled. So it is called a current controlled voltage source. And here if you see, arrow represents it is a current source. The magnitude is 2 times Iy. So what is Iy? Current through the 1 ohm resistor. So it is a current controlled current source. So in this case, if you see here, there are two independent sources, 90 volt and 40 volt, and one dependent source. So this is a voltage source because plus minus indicates it is a voltage source. And what is its magnitude? 2.5 times Vb. What is Vb? The voltage across this resistor. So this is a voltage controlled voltage source. Let us consider the ideal and the practical voltage source. An ideal voltage source, whatever current you draw from the voltage source, the terminal voltage will not change. So if you see here, the terminal voltage will be always equal to this voltage because there is no series resistance in case of an ideal voltage source. If you plot between VT and the IS, as the current increases, there will be no change in the terminal voltage. Whereas in case of a practical voltage source, there will be some series resistance. So due to this, when the current flows through it, there will be I into R voltage drop will be there. So VT is equal to Vs minus Is into Rs. So VT will be always less than this voltage. So practical voltage source, when the current increases, the voltage will drop. Let us consider an ideal and the practical current source. So in ideal case, we know Is is equal to I naught. That is, the parallel resistance is infinite, that it will not allow any current to flow through it. In practical case, there will be a finite resistance. So some current will flow through this parallel resistance. So this I naught, that is after this resistance or the output current I naught is equal to Is minus some current will be flowing through this. So it is the voltage divided by resistance. So that current will be flowing in opposite direction. So the net current get reduced. So I naught will be always less. Now let us see how to change a voltage source to current source or current source to voltage source. So you have a voltage source Vs in series with a resistance. We call it as a voltage source. Similarly, a current source is represented by a current source in parallel with the resistance R. So let us see how to convert a voltage source to current source or from current source to voltage source. So first let us see how to convert this voltage source to current source. So voltage source, first find the short circuit current. So you short the terminals and find what is the current. So when you short the terminals, this current Is will flow here. So Is is equal to Vs divided by R. So the equivalent current source will have this current Is and this resistance should be connected in parallel. So this becomes the equivalent current source for this voltage source. Similarly, let us see how to convert this current source to voltage source. You have a current source here. You find the open circuit voltage for this one. So what is the open circuit voltage? So what is the VOC is equal to this current Is into R. Because this part is open, this current will flow through the resistor. So VOC is equal to Is into R. So this can be converted into voltage source like VOC here, and resistance should be in series. Same resistance. So if you see some example, you will understand how we are converting. So first take a 10 volt source in series with a 2 ohm resistor. So now you want to convert this into a equivalent current source. So first find the short circuit current. So what is ISC? So current through this path is 10 volt divided by 2 ohm. So it is 5 amps. So the equivalent current source will have 5 amps in 5 amps here in parallel with the 2 ohm resistor. Same resistor. Let us take second example. So you have a current source here and 2 ohm resistor in parallel. Now you find the open circuit voltage. Open circuit voltage is this current into this resistor. That will be 10 volts. So your voltage source will be 10 volt in series with the resistance. That is very easy. Now what happens when you have voltage source in series? So two voltage sources are in series. So what will be the net voltage? V1 plus V2. Suppose you have 10 volt and 10 volt, you can write 20 volts. You can add it directly. When you have voltage source in series, you can add it directly. Similarly, you see the polarity here. Two voltage sources are in series, but you see the polarity. So the net one is the same polarity you have to maintain here. Voltage get added, but polarity will be minus plus. Suppose one polarity is plus minus and next polarity is minus plus. What will be the equivalent one? Plus minus or minus plus, it depends upon which has higher value. Suppose this is 10 volt and this is 5 volt, you will get plus minus. In case V2 value is greater, you will get minus and plus. Similarly, when you have two current sources in parallel, you can add it directly. So in this case, two current sources are in parallel. This current and this current get added. So it becomes I equal to I1 plus I2. When they are in pointing downwards, your current should be pointing downward. I equal to, that is, magnitude remains same, but direction of the current is opposite. Suppose one is pointing up and other is pointing down. What will be the net current? So this should be I1 minus I2, but net current direction depends upon which is greater. In case I1 is greater, arrow should be pointing up. In case I2 is greater, arrow should be pointing down. So the points to remember here are energy sources are of two types, voltage source and current source. So in that you have independent and dependent source. In dependent you have a voltage controlled voltage source, current controlled voltage source. Similarly, voltage controlled current source and current controlled current source. So a voltage source will have a voltage source in series with some resistance. Similarly, a current source will have a current source in parallel with some resistance. And if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.